I have tried to draw this problem number 1535, 35 problem from chapter 15, and I try my best to draw this. Let me explain this. This red line is the beam. This is the beam. I'm going to put another block. So that's the beam, and then it is having 12K load here and 4K load at D, and then it has a simply supported at point A and at point D, and then the C is the middle where between A and B where 12K load is. Now from our experience we can tell that the maximum will be towards the left of C, not at C. If there was no load, this 4K, if this 4K did not exist, then it would be in the middle of A and B where we'll have the max deflection. However, because of this load, the beam will try to crank kind of this way, and then it will create the maximum deflection towards this end. Now so let's say the max deflection happened from x distance from A. So the moment at that point we can calculate, we have 5 load, 5 times x, so that's 5x. We have 5k here, the distance is x, so 5k load times distance, that's the moment at this point. So I have drawn this individual moment diagram for that 5k, which is 5 times 30, total beam is 30, which is 150k, and then I have done that for 12k, and then I have 12 times 18, that is 216k feet, and then the reaction at B, which is 11, and 6 this is 6 feet from D, and then this is 12 foot from B, and then A to C is another 12 foot, like that. So the individual moment curve is drawn. Now when we say for example BA, why BA, what we mean by that is if we draw a tangent line at A, like this, and then what is the vertical distance from that line to point B, so that is the symbol BA means. So if we try to calculate using our second moment of area moment method, which is any deflection can be calculated summation of all area moment under the moment curve times their CZ divided by EI. So let's calculate that. So from A to B I have two pieces of moment, one is 150 and 216. That 4K does not come in a BA calculation, so I can say half times base, which is 24 foot times the moment. Now up to B, up to this point I have total 24 feet, and for that 5k the moment would be 5 times 24, so that's 120. So at this point is 120k foot. For this one, this point, the moment will be, I have 12k load and then 12 feet away, so 12 times 12, so that point moment will be 144k foot, like that. So here for the triangle, for that 5k load I can write half times base 24 times 120 k foot times the CZX. Now CZ is from calculated from point B, so point B is going to be 1/3 of 24 foot, like that, minus, because the area is under the curve, minus half times base, which is 12 times 144 whole square, 144 times 1/3 of 12, so 12 by 3, divide by 3000 30,000 ksi. EI, so E value of E is 30,000 and I is given 228 inch power 4. Now in the denominator, I numerator, I have 1 foot here times foot, so I have to convert 3 foot, so I have to multiply this by 12 inches is 1 foot, and then whole cube because I have 3 of those. If I do all this calculation, I will get a number something like 2.07 inch YBA. So if I get YBA 2.07 inch, then I can compare I can compare the triangle. Let's say this is B prime, and then this one is D prime. So I can compare the triangle AB prime and then and D prime. So if I compare these two triangles, then I can write Y I can write YD by YBA. So bigger triangle height divided by smaller triangle height equal to bigger triangle base, which is 30, divided by smaller triangle base, which is 24 foot. So I don't have to convert anything, it will cancel out. So YD, I can get YD is equal to basically 30 by 24 times 2.037. This is actually 37. So YD is equal to, is calculated 0.7275 inches. So I know YD, I know YDA. Sorry, that was actually calculated 2.5465. Let me double check that one more time. So that's correct. Then I can now calculate the delta D, which is equal to YDA minus YD, which is it would be then YDA. Oh, we didn't calculate YDA. Let's calculate YDA. So we can calculate YDA by using the same concept, basically all the area up to Y. So half times the longest triangle, which is half times 150, half times base, which is 30, times 150 times 1/3 of the distance, which is the CZ, that's 30, minus half times 216. Let me use one other page. So to calculate YDA, it is half times summation of all area times the x bar divided by EI. So it is basically half times base was 30 foot times 150 k foot times 1/3 of 30, that's the CZ, minus the second longest triangle, which is half times base is 24 foot, 216 was the moment height, and then the CZ is 1/3 of 24 foot, plus the smallest triangle, which is 1/2 of base 6 times 66 times 1/3 of 6. So that, So all of these has 3 foot, so foot times foot times foot, so that's foot cube. If I have to convert that to inches, 12 inches 1 foot, divide by 1 foot, that will cancel, and then in cube. Divide by EI, which is 30,000 KSI times 228 inch power force. So that will be dA is, I found 2.8375 inches. So that's YDA. And then in the previous page we calculated Y D was, let me go back and see what was YD. So YD was calculated, that's 2.5465. So YD was calculated 2.5465. Then we can calculate the deformation at the free end. Delta D would be basically YDA minus YD, so that's gonna be 28375 minus 2.5465. so if we do that, we get something like 0.291 inches. So that's delta D, the free end deflection. So let me go back and show you. So this was calculated, was equal to 0.2, I think that's 0.291 inches, like that. Now we want to calculate the maximum deflection. We said that it's going to happen at x distance. So to calculate maximum deflection, what we can do is we can use the first area moment equation, which is theta, and theta can be calculated from YBA and then AB. So if we calculate theta, and then so we can calculate theta from the first area moment equation, which is summation of whole area up to that point divided by EI. So that is one. And also we can then do tan inverse YBA divided by just AB is equal to summation of whole area divided by EI. So that tan BA, that is BA was calculated, let's see, what was that? So BA was calculated tan inverse 2.037 inches divided by AB was 24 foot times 12 inches is 1 foot is equal to, then the moment from x distance, area under the curve, would be half times base x times the height, which is 5x, that's the moment, and 30,000 times 30,000 KSI times 228 inch power 4. If we want to find x in foot, then we have to convert that to inch. Imagine this is in foot, so then 12 inch is 1 foot, and I got 2 of them, so whole square. If you do all this calculation, you're gonna find x equal to, let's see, 11.59 inches. So 11.59 inches, and then so we calculated this distance 11.59 inches, this one, between A and that max point. Now all we have to do is calculate YCA using that equation, the second area moment equation, and then also YC. We can compare triangles to get YC. Let me name this something different. It's looking confusing. Instead of that, we are trying to find out the max. Let's name that as E. So that point, name this point as E. So if that point is E, so it's going to be Y EA and then YE, like that. So we can calculate YEA, and so let's do that. Let me have another page and then. So YEA, we can calculate half times base, which is 11.59 inches, times the height, 57.96. If we multiply this times 5, and then times the 1/3 of 11.59, that's the CZ, divide by 30,000 KSI times 228 inch power 4. Now here I got K foot, here I have foot, so I have to convert this. So 12 inches is 1 foot, and then I got cube, so let's cube that. If we do this calculation, we find 0.378 inches is YEA. Now we can compare that two triangles. Let's go there, the first picture. So we can compare AE, let's name that as E prime. So AE prime and AB prime, maybe, then we can get YE. So let's compare that. So if we compare triangle AE prime and triangle AB prime, we can write that YE, the small triangle height, divided by the small triangle base, which is 11.59 inches, times is equal to the small triangle, the large triangle, which is YB. So we can say YBA divided by the large triangle. Actually, this is in foot. Last triangle base, which was 24 foot, and this was calculated. Let me see. 2.03. This was calculated 2.037 inches. So you can find out YE is equal to. That is calculated. Didn't calculate that. Let me calculate that. So this one I have found 0.9837 inches. So we can find out delta max by delta max or delta E. It's the same thing. That would be YE minus YEA. So if I do that, it's going to be minus 3.378. So I found 0.61 inches. All this number is reasonable because a 30-foot long beam, if it's only deflect about ½ inch max, so that's a reasonable number. So that is one answer. And then the free end deflection we calculated before.